Good morning, students. Today we are going to discuss about the control system. Already we discussed various component of the control system. As you know, process, measuring element, controller cum recorder, and final control elements are the four component of the control system. We have discussed all these control systems one by one. We developed their block diagram, and today we will discuss about some problems related to this control system. So first we are going to discuss a problem 5.1 on page 181 is a problem of two heating tank process connected in a series. A flow of heat enters into tank 2. It is not entered into a tank 1. So the water temperature is dropped down from 60 degree to 52 degree Fahrenheit, and the flow rate of tank suddenly increases according to a step function of 1000 joules per minute. So these are the changes occurring into the inlet water temperature and heat flow. We have to develop the block diagram that relate to the outlet temperature of tank 2 to the inlet temperature of tank 1. We have to find out T2 dash, where T2 dash is a deviation in temperature of tank 2. We are going to find out T2 at t is equal to 2 minutes and T2 at infinity. We will find out the response for T2 dash versus time. So this is the data given. Initially T1 is equal to Ti is equal to T2 is equal to 60 degrees Celsius and Q is equal to 0. The W, the mass flow rate is given to 50 kg per minute. Hold up volume is 5 meter cube. Density of the fluid is 50 kg per meter cube. The heat capacity of fluid is 1 joules per kg per second. So this is the diagram for the two chemical reactor control system. So first we have to write the unsteady state energy balance over tank 1. So now if you want to write the unsteady state energy balance, you can write mcp delta T is equal to mcv delta T. Is it right? So we'll write m is here is W. So W into C into temperature Ti minus T1 for tank 1 is equal to rho Cv, because rho into V is mass m into C into dt1 by dt. So this is how we can write the energy balance over tank 1. Now divide this equation by Wc. Okay, you will get the term for tau. So tau will be rho v by W. So you can write the equation for tank 1 as well as you can write the equation for tank 2. Now what will be the equation for tank 2? It will be nothing but Q plus Wc T1 minus T2 is equal to rho Cv d2 by dt. Again you divide by Wc, you will get the again equation in form of tau. Now writing the both equation, its steady state, introducing the deviation variables, subtract both variables, introduce the deviation variables and take it Laplace. You will get this following as a equation. The first one will equal to T1 dash minus Ti dash is equal to tau into T1 dash of S. Is it right? So T1 dash by Ti dash is equal to 1 upon tau S plus 1, and the second equation becomes T2 dash is equal to 1 by Wc into 1 plus tau S Q dash of S plus T dash of S. Is it right? So you can find out T2 dash from this. You can find out the T2 dash of S, and then you can find out, you can solve this to find out its inverse Laplace. So you will get T square by S, whose inverse Laplace is tau square upon S plus 1 by tau. Its inverse Laplace is tau square into e raised to minus t by tau, and the third one will be minus tau t into e raised to minus t by tau. So putting the value of t is equal to 2 minutes, you can find out t2 of t. You putting the value of t is infinity is equal to minus 4, you can find out t2 of infinity is 56. Then put the various value of time and plot the graph for t2 dash of t. So this will be the graph for t2 dash of t versus time. Now once you do this, then you can develop its block diagram. This will be a block diagram which relates t2 dash, t1 dash, ti dash and q dash.